I'm gonna start with number 2 actually, because this is more of a normal way to set up a while loop. You can look at your screens or mine. What I mean is, the increment comes at the end on this problem, and so it's going to be more like you'd expect. What I highly recommend on loop problems is make a table, a trace table, and so you have two variables, m and total. What I like to do is make the headings those variable names, but also give them the initial values, which obviously is just given right there. And then run your loop, and you can keep track of what's happening as you run the loop. Okay? And keep in mind, you know what? You have to be aware of what the variables are storing at the time you run this code. So obviously, if m is 2, it's less than 6, so we do keep running. It could happen, by the way, like if this condition was replaced with that, then would that be an error? Well, not exactly. I mean, this code would compile, it would run, it would just do nothing. The corporate response would be no output. That's actually what the output is. So it's maybe a logical error. Like usually, you may not want the loop to never run at all, but you can have it. The Java's not going to complain about it. So anyway, so we're going to run as long as m is less than 6. Total equals total plus m. Once again, it does the right side of that statement first. It gets the current value total, which is what? 0. Current value of m. And actually, here, I'm sorry. Right now, m is 2. And so right now, the current value of m. And then this is going to calculate, and the 2 is what was compared to 6, by the way. And so whatever the value of m was, you know, when you start the loop, is what I wanted to put here. And then total equals 2 plus 0, so now total is 2, not 0. And then n becomes 3 for the next time. And we go back to the top of the loop with m being 3. And we repeat it. And so once again, right now, total is 2, m is 3, so total becomes the sum of 2 and 3. That's your new total. And then m becomes 4. You go back to the top of the loop, m is still less than 6, so you run it again. What's the new sum? Plus 1 is 9. And then m plus plus happens, so you're up to 5, and you repeat. And you run it again, and so 5 plus 9 is 14, m becomes 6. Now, that's one thing I want you to realize. M did become 6. What happens when m is 6? It's nothing, right? The loop doesn't run again. And so, usually we just don't need to put that in the table, because that's not a value that the loop ran for. It isn't a value that made it true. But you need to be aware, if down here I chose to print m, it would be 6, not 5. Basically, the counter variable, whatever's controlling loop, it's going to end up being the first value that makes the condition false, not the last value that makes it true. Because that's how the loop ends. Okay? And this problem, it doesn't matter. We didn't care. All we cared about was the total. But just keep that in mind. And by the way, so what numbers did we sum up? 2 through 5, right? We started at 2, and we did everything less than 6, which would be numbers 2 through 5. And that's what I'm saying. This is normal, what you'd expect if you read this code. Go back to number 1, and what the key difference here is that the increment comes before the print. And so it's not going to work out the same. Let's do another trace. You only have, and frankly, we're just printing this time, so I'll just print it out. The first thing tested is 1, but then the 1 becomes 2 here. So the increment happens, so the first thing printed is actually 2. You go back to the top, and 2 gets tested, right? But then in here, I tested it, then I just did that, and then I print it, so I see the 3. Move back to the top. X is 3, so it tests true. X becomes 4, and the 4 gets printed. We run it again. So X is 4 right now, which makes it true. So it becomes 5, the 5 gets printed, and you start over again. Now, that test false, so we end. And the kind of odd thing is, you notice, X started out as 1, but the 1 was never printed. And the condition said to do everything less than 5, and yet the 5 did get printed. Troy, here. Troy. Thank you. And so that's what I'm saying. This is abnormal to have the increment first. But with while loop, you can put it wherever you want. You can put the increment in the middle, before. This is short. We only have two lines of code, obviously, but you have longer loops. And so that's what I need to understand. We'll do for loops, and with a for loop, this automatically goes to the end. And so a for loop is kind of like a special kind of while loop. All right, try this one. Try number 3 on your own now. You should have gotten 42. So, all right, look, let's go through it. So z starts out as 2. And then sum starts out as 0, those initial values. That's supposed to be a z. And once again, z, the first thing tested is 2. Let me run it step by step. Z becomes 3 though. And then, so the sum becomes 3. At the time the sum is computed, it's adding 3 plus 0. You go back to the top. I don't know. I'll leave that the way it is. And then with z being 3, it's going to increment z to be 4, and then compute the sum after that. And you just keep repeating that. With z being 4, of course, it's true. It becomes 5, and so the sum is 12. And it keeps going as long as z is less than 9. And so to increment first to 6 and add, increment first to 7 and add, and just keep repeating. If you had 8, you get 33. Now, let me pick it up right there. So once again, we just finished the last loop with z being 8, and which makes the condition true. But then it becomes 9, and then the 9 gets added on. And we get the 42, and then you go back to the top with z being 9 and it stops there. But once again, which numbers actually got added? Not the 2, but only from 3 on all the way up to and including 9, which once again is abnormal. Okay? And so that's your 2 kinds that we'll throw at you. Now, let's do one of these. First of all, we're kind of building up an output. In other words, S is initially an empty string, which is okay. There's nothing in it. And so here, let me try to draw this. K starts out as 3. S starts out with nothing. It's just an empty string. Okay. And so first time through, K is 3, of course, and which makes this true. And then this changes S. What is S currently? Nothing. So you put 3 in a space in front of that nothing, which means you have 3 in a space. So that's what S stores right now, is that string. 2 characters, a 3 in a space, and then K decrements by 1. And we go back to the top with K being 2, which of course 2 tests out, so we can repeat. And listen, we'll throw this at you a couple different ways. Focus on this part here. If they switch the order, that'll change how the output looks, okay? But right now, S right now is a 3 in a space, K is 2, so you end up with a 2 in a space in front of the 3. So now the string becomes 2 space, 3 space. Because that's what it says. Put the current value K in front of S, the current value of S. And then K decrements to 1. And we repeat. So K is 1 right now, which of course still makes it true. And so the 1, K is 1. And once again, S is the 2 space, 3 space. So once again, you get 1 space, 2 space, 3 space. And I'm gonna stop showing the spaces. And once you get the idea, you can go faster actually. K is gonna become 0, and so you get 0 space, 1 space, 2 space, 3 space. So K was 0. Well, we just finished K is 0. Okay, we just did that. And so this now makes K negative 1, which tests false, and so we end right there. Once again, pay attention to that. Final value of K was negative 1. What was the final value that made this condition true? 0. Well, that wasn't the final value of the variable, and never is. Now, sometimes you'll see the negative 1, this time you don't. So just be careful. Okay, pay attention. All right, try the last one on your own. Okay. Frankly, I was hoping that this would have been. It's still in the same order. You notice it has B in front of the list, and so it's going to be the same as the last example. Okay. First of all, notice once again, B starts out as 5. 5 is what gets tested, but then it becomes a 7 before anything happens, right? And then this was, well, what does this mean? Yeah, good. It's called the modulus operator. And so, look, if I do 7 mod 2, then you say, okay, how many times 2 goes in 7? 3 times, which equals 6. Subtract, you get remainder. The remainder is 1. So that's what modulus gives you. It gives you the remainder from the division. If I did the same thing with 8, what would my remainder be if I divide by 2?
0.
Right, because 8's an even number. And so that's how we test for whether it's even or odd. We divide by 2 and see what the remainder is. And so just get used to seeing this and saying, here, write that down. Is B odd? That's really the question that we're asking here. That's what that means. If you divide by 2, you get a remainder 1, you're done with the odd number. And so if that's true, then it is part of the list. And so 7, of course, is odd. So 7 gets part of the list. And once again, it's a 7 in a space, and then whatever the list was, but the list was empty initially, so all we have is 7 in space. And then you're just going to keep going up by, well, actually, right now, let me start over. Right now, B is 7. Like we just did this line of code. And so we come back here, test is 7, is true, so B goes up by 2, and it's 9. Frankly, the way this is set up, every number we're going to run to is odd, isn't it?
Yes.
Because we're going by 2s.
Yeah.
So it's kind of redundant, I think is the word. Because we're only going to hit the odds, so this is kind of unnecessary. And once again, because the order is doing the current value of B, which is 9, and the current value of list, which is the 7 in space, so you get 9 in front of the 7 space, so it's 9 space, 7 space. And you go back to the top, the 9 gets, you get the 9 tests true, and so it becomes 11, and then the 11 gets tacked in front. So 11 space, 9 space, 7 space. You go back to the top with B being 11, and now it's false, and we end right there. And so once again, because the increments before, the initial value 5 never saw, never got printed. And the last value, the value that made it false, did. Okay? All right, turn the page over. Let's do the other side.